an exam question.
Yeah.
Oh my god, there's so many words on that page.
It's so neat, and it's not that.
It's all legible.
He's got a nice writing, indeed. So it's every something worked here yesterday, but so question one was the basic early topics in group theory. Definition of a group. Prove and discuss an example. Definition of subgroup, and standard book theory, a couple of standard book theory results about subgroups. Yeah? Okay. Question one, which, if you're doing a group theory exam, you want to be able to say what a group is. So the question says a group is a non-empty set with, and I do it like this is how Judson presents it. Judson incorporates the closure condition into saying what a binary operation is. Okay? So fair enough, some people present it like that. So a binary operation on G is a way of combining elements, which gives you another element of G. Not every book will present it like that. To say some other element to some containing set. So the question says there are 3 extra conditions needed for the pair to form a group. What are they? And explain their meaning. So Jan's named them as associativity, identity element, and inverse elements. And he's given the kind of predicate logic form of each one. So associativity says for every triple of elements, 2 different ways of evaluating the triple product come to the same place. Yeah. G1 star G2 star G3 is the same as G1 star G2 star G3. That's associated. Okay. So important things there. You would need to indicate some in words or symbols for every triple of elements from G. Yeah. Not just the equation. If it's just the equation on its own, it's slightly deficient. You need either in words or in symbols to say this applies to every triple of elements. Second condition, exists an element denoted E satisfying this property, which is for every G, G star E is equal to E star G. And this is the G. Pretty clear? Makes sense? The identity axiom. Sorry? You're already on, going too slow. Okay, inverse elements. For every G. Interestingly, he's not introducing the superscript -1 notation, which is fair enough. So for every G, there exists a H, G H equals H, G equals E. Okay, so I'll speed up.
I'll be here on slow, it gives me a chance to write down.
So he's saying, so this is, I guess, in response to explaining their meaning. First is clear, yeah, pretty much. Second means the group needs to contain an identity element that operates as above, fair enough. Third, every element has an inverse element, usually called G1 inverse. G inverse, sorry. One is belongs to one. Okay. Yeah, would everybody give that full marks?
I'd say so.
Yeah?
I'd want full marks for writing that.
Is the written bit necessary? Like if we just
It depends how much you write at the top, doesn't it, really?
I'm not putting much.
No, I guess where it says explain their meaning.
Yeah,
At least a few words.
So that's
Yeah.
your interpretation.
yeah, oh yeah, so like we're not saying this and only this. Yeah.
I didn't
As
write
the
the
market.
question. I didn't write the question, and so I'm guessing what
Yeah.
you meant by this question, just like you will be. So when it says explain their meaning, I didn't really know what to do.
But
So
you
I
should
put-
be, yeah, but you should be willing to give a little bit of explanation and contextualize stuff and demonstrate your understanding. Yeah. Because I think the worry is that somebody just learns off by heart these strings of symbols and has no conception of what they mean. Yeah. So at least if you talk about it a bit in a few sentences, slightly illustrating, talking about, at least giving like an English version of this kind of thing, then.
You want us to talk about it as well as you want it like that.
Well, so what Jan is, so we would give full marks to what Jan has written there. Yeah, so he's not added that much to
I
it.
don't
But
think I would write.
If I'm being honest, I, as a group theory expert, would have just marked it full marks for the 3 bullet points.
As a group.
Yeah.
That's a group theory
Yeah.
expert.
I've basically, yeah, because I've just done
Maybe
those
you're-
3 bullet points.
I think
See.
you're more close to Jan than, yeah, that's, I think, how Jan
No, I mean, I stopped after the 3 bullet points, and now to explain the meaning.
I-
What does he really want? Okay.
Yeah.
Just to be sure.
is. To be sure,
I'm
just
not
emphasize it.
emphasising
In
it.
an exam, you always just write and not as a problem. Just write down
It all-
Yeah, yeah, absolute. This
Similar
is-
with the coursework.
Okay,
Is that
This
I
doesn't
mix,
actually answer your
I
question,
matrix
but have
of
3
I
pages.
turn out of I equal 1.
well, we're going to start and we're not discussing that yet. So let's look at that now, yeah. Part B.
Oh, I really didn't do
So this is an answer to part B. Part B, prove that the pair GLNR times forms a group where that denotes the set of n by n matrices. Zero determinant. Let's multiplication. Use any relevant properties of matrices and determinants as long as you clearly state them. So we're not looking for a whole load of linear algebra proof, matrix proof. Just refer precisely to the known facts from linear algebra that you need to call upon. Okay. So Jan begins by putting down properties he knows are going to be relevant about the determinant. He clearly states them. Determinant of I is 1, where I means the identity matrix. Determinant of a product, I'll put brackets in there. Okay. Determinant of a product AB is the product of the determinants for any n by n matrices. And determinant of A, an extension of this, is determinant of A inverse is 1 over the determinant of A. Okay. That's all the kind of multiplicative type properties of the determinant. And then he states GL and R is a group. Let AB be n by n matrices, IN be n by n identity matrix. So then he's addressing the 4 properties that you've already laid out in question 1a. First of all, closure. AB is an n by n matrix, and so he just says if you multiply 2 n by n matrices, you get an n by n matrix. Fair enough. If the determinant is non-zero, determinant of B is non-zero, then clearly this determinant, being the product of those 2, has to be non-zero. Therefore, AB is in GLNR because AB has non-zero determinant. Okay, so he's fully addressed that point. Associativity. I just said, well, associativity of matrix multiplications. Okay. It is kind of composition of functions under a different kind of. Anyway, identity element. A matrix property that IN has is when you multiply by any matrix, it gives you back the same matrix. Fair enough. And specifically, this is important, it is present in GLNR because it has a non-zero determinant, namely determinant 1. Yeah. Just saying, strictly speaking, you left off this point here. All you're saying is somewhere there's floating an identity type element. You need it to be present in the set. So he justifies why it's in the set. And last point, okay, from the theory of linear algebra, if the determinant is non-zero, there is an inverse matrix, which has this property. Which is, we can see, yeah, without any further thing, that is the group theoretic statement of the property of an inverse. And again, you've got to justify, not only is this object A inverse floating around in the ether, it's in this set, because it has a non-zero determinant. Reciprocal of non-zero is non-zero. Full marks for Jan?
Yeah.
Yeah,
He's doing good.
not full marks for me, so I'm really glad we didn't
Full.
use mine.
He does need an asterisk, so he is a doctor in mathematics, so I don't think getting very much.
Asterisk. Where does he need the asterisk?
Just a note to
Next-
add.
next to his
Actually,
marks.
I have a PhD, so
Okay,
my
yeah,
answers
yeah.
don't even count. Automatic zero.
If he's not getting full marks, we should be worried.
Yes.
We
I'll
need 3
scale
hours,
it.
he needs 3
So if he's getting
minutes.
full marks, ours are roughly worth 100 marks for every mark that he gets.
Yeah. So it's only fair, really, isn't it?
Apart from Bigger Bezit, because she's like 50 to 1.
This kind of thing is a form of therapy for Jan, I think, because normally Jan would be working on problems he's stuck on, you know, you're probably like, I don't know how to solve this problem.
Oh, so
Okay,
this is his
so this
easy
is-
maths.
this is
Like
like-
when we
Like-
go back to GCSE.
Oh, I love to do
Yeah.
it sometimes.
Love
I
that.
say that because my new class went through, they gave me a GCSE paper.
This is easier than you going back to GCSE.
Our
He
level,
would
yeah, but
struggle
our
on the
level is
GCSE
different.
paper.
That's what matters.
Have I shown you how hard it is like
I
Christmas
thought
chocolate?
Think like
Yeah. Like what
calculations
like,
with
like,
signs and
we
cosines.
struggle.
Yeah, yeah.
with the angles.
He'd probably get about 70% on GCSE.
I'm about to call them all.
Okay, any comments or questions about Part B? Things you're unclear of, how you'd approach the answer? And, you know, this direction is there to, we don't want you to get bogged down in giving loads of linear algebra explanations. Just state the thing clearly and present it as it applies to the groupiness of this.
Grittiness.
Is that the technical term?
Or
Okay, C, definition of a subgroup. Everybody's got this in front of them, don't they? Yeah. 2 marks, just hit the nail on the head. Subgroup of a group G is a subset H, which is a group under the same operation as G. Restricted to H. We use this word. Considered as it applies to things in H. Yeah. Full marks, yeah. That's what a subgroup is. Okay. Just like a subspace of a vector space.
This could be a stupid question.
No questions.
Oh wait.
Apart from the really stupid one.
No, it was just that obviously we've learnt a lot of definitions since the beginning of group theory.
Yeah.
I mean, you can't tell us what's in the exam, but like on your little summary sheet, is it going to be like examples of what?
I think it'll
Or could you
say,
ask us anything?
I think it'll say all definitions.
Okay.
Certainly the definition of a subgroup.
Oh right.
Well,
Yeah, that one was
yeah,
right.
but what we mean is like because obviously the definitions get kind of long in the later chapters as well. Like there's
Well-
a lot of
This is still level
They
one.
are.
Which one?
there's so much content. Just know what.
That's okay. That's cool.
No, but I think-
I'll learn.
Flashcards.
Some definitions, if you look at questions, they might be kind of woven into the statement of the question, telling you the definition. But I think pretty much,
Like, when you look at these examples, stabilizer, orbit,
yeah,
Yeah, that's
yeah, you'd expect to know.
polymorphism, isomorphism, normal subgroup.
And so the key definitions then basically.
I think when you actually drill down and look into it, I think
There
you,
aren't so
To be
many.
fair, for
I think
definitions.
you would already know.
Yeah.
Yeah.
I think
Orbit and stabilizer, they're probably getting into some of the more trickier ones to state correctly. But I think better family and practice the rendition of those. Okay.
basically what I'm asking is please don't throw us a curve.
Yeah, yeah.
What is this thing called calm?
Okay. So what's question D? Yeah. So this is one that there was a bit of back and forth about this yesterday. Does everybody see the front of them? So this is establishing one of the subgroup characterizations. Yeah. We have a definition of a subgroup. That definition is perfectly good, and if you're given a candidate subset, you can go and test whether it's a subgroup or not according to how we just answered part C. But part D is like a more efficient way, a kind of compactification of all the necessary stuff. So H is the claim is H is a subgroup if and only if H is non-empty, and for every pair of elements GH, we have GH inverse is an element of H, which is a mixture of the kind of a mixture of the closure and inverse conditions. So Jan, like we discussed yesterday, what you're asked to prove is an if and only if. So he's using this shorthand notation, which is acceptable. The first bit is the left to right direction. The second bit is the right. So the first bit is the left to right. The second bit is the right to left. Yeah. So I guess when we're reading this, we implicitly assume H is a subgroup. Yeah. He's giving a direct proof of the left to right implication. So we assume H is a subgroup.
Okay, maybe that's the mark off.
Maybe, yeah. And a mark to subtract. Okay, so you should make clear his assumptions, or at least he could say, proving this directly or something. So then, so we assume H is a subgroup, so we have to prove it's non-empty. So he's got 2 bullet points: prove it's non-empty, prove it has the funny mixture closure inverse condition. Why is it non-empty? Bang, because it contains the identity. Right? No more needed. Okay, groups have identities. Second one, okay, he declares this little bit subtlish point. Obviously, he says the identity in the group and its subgroup is the same element. That's a kind of consequence of the definition of an identity. It kind of has to be unique, but he's not getting bogged down. He's just declaring it again. Also, he says the H inverse referred to as the inverse element for the group H is the same H inverse, which is the group, which is the inverse from the group G. Okay, because H is a group, I guess he's also saying he's starting off with a little g and a little h in H. Because H is a group, H inverse is present, yeah, because it contains all inverses, and therefore the product GH inverse. Yeah, because H is closed. Okay. Established H inverse is in it. You've implicitly assumed that G is in H, so therefore, oh yeah, no, he says for any G in H. So yeah, so a criticism of that is maybe make the assumptions clear at the top. Yeah, that's kind of what this little label of a this way arrow and a label of a that way implication is kind of saying, but to be clearer. Okay, good tips for you whenever you're trying to do a proof or whatever.
So we need to add something to it.
Ideally, it's an easier read if you make it clear the assumption at the top for this part of the mini proof, namely, assume H is a subgroup of G.
Yeah, but that was on the time question.
Yeah, well, indeed, fair enough. And we are slightly forgiving of those things in an example. But I think there's plenty of time to do it. Everybody okay with that direction? Yeah. So going the other direction is you assume the 2 bullet points are true. Yeah. For a subset H. And then the goal is to prove H is a subgroup according to the definition you've given in part C, which is that it forms a group under the operation. So we got to prove closure, existence of identity, existence of inverses, and maybe say something about sensitivity. Okay? Which he starts off with. The group operation is associative in G. It's also associative in H. It's just H is a restricted domain for the elements. So all triple products are still ambiguous. Is there an identity element? Question mark. Sure. Okay. So all we know is that H is non-empty. So there's something in H, call it little h. By the mixed, the second bullet point condition, we're assuming this product must be in H. But within the context of the group, this product we know is the identity element. So the identity is in H. Now that we have the identity in H, now we're proving inverses. For any H in H, so you're taking your G as the E and your H as the H. So then this product must be an H, and that product is H inverse. So H contains an inverse element for every element it contains. And last, so this is the curious thing, closure you end up proving that last, whereas in the original presentation of the definition, closure comes first. So that might have thrown you if you were desperately trying to prove closure first. You wouldn't be able to, because you kind of needed to prove these first. So finally, you can do closure. So if you take a pair G1, G2 in H, we know G2 inverse is in H. So making these assignments to this condition, we've assumed G1, G2 is in H because, and we squeeze this in. Okay, so using this condition, we say G1, G2 inverse is in H, but G2 inverse is G2. Fair I think if I was marking that, I'd be wondering, should I dock in 1 or 2 for not making the assumptions clear? But then I'd be so impressed by the accuracy of the argument. Labeling, I'd probably say, benefit of the doubt. He's done everything correctly, and these labels
This is 5 maximum.
kind of suffice for that.
I was most of this one at the beginning, and I put like, let's say this H as a subgroup. But then when I started going the other way, I actually just rolled the other way. So, 5.5, I reckon.
Well, that's better, because at least he did it properly once, and then similarly go the other way. Any queries about the detail of that? So yeah, there's a slight complication in the second part in that the order, each one, the order is built up in a specific way. Closure comes last. Because you always read the definition, closure always comes first. Maybe you might struggle trying to prove closure off the bat. Okay. Okay, part E, think the center is a group. Center, label Z, centrum. You've got the definition of it. Now, here you make a choice how you're going to approach the question. Do you use your original definition of a subgroup, which separates out, show it has the identity, show it's closed, show it has the inverses? Or do you use the results of the previous part, probably what I was thinking, what I was trying to guide you down. You've just gone to the trouble of establishing this subgroup characterization thing, so maybe you should use that. And that's what Jan does, isn't it?
Well, that's what I started doing, and then I decided it would be better to do it with this.
Okay.
But now
I
which one
did.
I should follow?
Identity,
Well,
inverse,
Yeah, so
closure,
I started doing
and
it,
stop.
then just delete it.
Ah, yeah. So his first sentence was ZG is non-empty.
Because.
It looks like a 0, it should be the empty section. It's a joke scribbling on.
Okay, so then he resorted back to just showing.
In fact, I'm using position 331. No, 330.
Yeah.
Okay, so he's referencing that first subgroup theorem. If E, all its products and all its inverses are in G, then ZG is a subgroup. So all that leaves out is just the fact you don't need to establish associativity, because that's already given, because you've got associativity in G, which is a subset, or ZG is clearly a subset of G, so clearly the operation is associative on the subset. So the identity element meets them. So this is the membership criterion for being in the center. X has to commute with everything. Does the identity commute with everything? Yeah, that's part of the definition of the identity. So E is in the center. If X is in the center, so the goal here is to prove X inverse is in the center. And you do it some kind of inverse of an inverse kind of thing. So you focus on G inverse. So you choose an element, an appropriate element from G. We're calling it G inverse. And we know, so this is what we know in the middle. We know this middle equation, that X commutes with G inverse. Why? Because X is in the center, commutes with everything. So in particular, it commutes with G inverse. But then these two elements, their inverses must be the same. And the inverse of this one is X inverse G. The inverse of this one is G X inverse. So then beginning to end, you've got the required equation. X inverse commutes with this little G. And this little G is chosen without any restriction from the group G. So X inverse commutes with everything.
Is that sufficiently explained for Mark? So we
Well, I would say, given that in the earlier part, you've already made the point that an inverse of an inverse is the original element, I'd say, well, do you think it's sufficiently explained?
That makes sense.
It's not. So we know
It doesn't.
You won't say
I
like
can't read
the
my
middle
own. Yeah, I can't.
equality, this is because X is there.
Yeah, perhaps.
This is because.
Yeah. I mean, maybe to put these, rather than all on one line, to put each equation on a separate line so you can stick in the justification after. So the justification for this is inverse of a product rule. Yeah. The justification for this is because X is in the center. And the justification for this is again the inverse of a product rule. That might be clear.
who's going to be the second one for your part of the exam?
I'm going to actually, Jan by this time will be yodeling in Switzerland, so I'm going to mark it up, and someone else will check my marking.
Someone who is familiar with human. Or like, you know,
No,
because
I'll rigorously do the marking, and somebody else looks
I
over
mean,
it.
nobody
exam,
checks the
someone
marking
else.
anyway. Like, if you're under the impression that if there's an exam in like linear algebra and programming skills, that Norman checks Steve's marking and Steve, no, that's not.
We rely on,
Can you
so
stop the recording? Or if
First
you're
chapter.
marking- Or if Killian and I are marking group theory exam, Killian's got 3 questions, I've got 3 questions, you're not looking what we did.
but somebody
Well,
looks
no.
at, somebody
No,
looks at all the
but-
papers and checks, they check that everything has been marked, and they check that we've allocated all the marks for particular questions. But at the end of the day, it's like it's my academic judgment when I'm marking the thing.
Like, it's not like there's somebody who checks that we've not missed something
Yeah.
and not completely non-marked it, we've added all the marks correctly together and things like that.
That's been the case all
And
the
then-
time.
I
for
think
a-
you forgot to sometimes to add all the marks correctly together.
Yeah. But then,
I don't
then
think
for a selection of the script,
Just
somebody
want to
looks at them
remind
and
you.
says, okay,
Please make sure.
To be fair, it'd be hard to find someone who would even be able to invigilate your marking it.
And that's been the practice of it.
I'd love someone
That's the
to
practice.
read my work.
And
It'd be funny.
Just when you're marking, make sure you're just be kind.
no, I've always got loving kindness in my heart. But, objectivity as well.
okay, now I've put that.
Yeah, so here he's slightly better argument, okay, so he's got his little justification in there. But, you have to be quite compact to do that. There's plenty of paper in the exam. Maybe do it
I
as
write
separate
everything.
lines, you got plenty of room.
It's actually quite fun to see the solution. Yeah.
So what's he doing here? He's doing closure.
So,
So you assume X, Y are elements at the center. From beginning to end is the goal, because you want to show that the product is at the center. So when Jan is laying this out, he's straight away, he knows he has to establish this. So that's the goal. This is quite like, when you think of how I present the number theory stuff from last year, you know what you have to prove. You have to prove that. So it's just a matter of working on this and transitioning to that. Yeah, through fully justified steps.
Yeah, it was kind of obvious how it's going to work. So I could do that.
Yeah. So there's like associativity going on here. What you can flip Y and G because Y is in the center. Associativity again. Flip X and G because X is in the center. Associativity again.
wow.
So this is an example of where someone raised the question yesterday, do you always have to point out every application of associativity? Well, it really does hang on crucial applications of associativity here, and it's a relatively early on matter about proving subgroups and stuff. So I think it's appropriate here to
This is a
clearly illustrate the role of associativity. And then he appeals to the theorem, but
You just crossed out your entire answer.
you could just do these three
I
and then
wasn't
just have a
answering the
fourth
question.
bullet point
You were.
saying associativity doesn't need to be proved together. We already know operation is associative on H.
But that one is associated with the other thing.
But he's using associativity
Okay.
here
Okay.
to prove the closure axiom. So here's the closure axiom.
Oh, okay.
X, Y is a
Yeah,
subset, then the product is the subset.
Thank you.
Yeah.
So we can use associativity to prove the closure.
Yeah, you have to use it. Yeah.
Maybe that will go.
It's the only way to do it.
G.
Because you have to kind of separate out, you have to switch the emphasis from the product XY to X times the product YG in order to use the fact that Y is in the center. Because the fact that Y is in the center means every product YG, you can flip to a GY. Yeah? That's the definition of being in the center. Being in the center means you commute with everything.
No, this is a different question. Yeah, that's why I was like, I have no idea. No, you were looking
So
at
yeah, that'll
Y.
get full marks again. So
I did I flipped it off. Oh, did you? Yeah.
is that okay?
No, it's not wrong because I got as far as X, Y equals G, X, Y, G inverse, and I just needed
No,
Just-
we're only good for now because I didn't explain it.
Yeah, I mean, yeah, like if
each step.
that's another thing. Like if somebody is on course for, I don't know, should I say this? I mean, if somebody is in and around 90 and one, you know, maybe you're requiring exactness.
No, 23, I'm happy.
I've got a lot in either.
Oh,
So,
So yeah, so you could have improved this by justifying each step here. And the presentation of the, I think Jan was talking to himself here. If you're
application.
talking to a reader, talking to a marker, you want to make clear your assumptions. And be a little bit more explicit.
Yeah, but come on.
But yeah, you could argue the case.
Like if I put that arrow, that means I'm assuming the left and I'm proving the right.
If you're doing a direct proof, what if you're doing proof by contradiction?
Well, if I'm doing a proof by contradiction, I say by contradiction. That's
Well, yeah, okay, but by the same token, doing a direct proof.
Cool.
I don't say anything else. I'm doing that.
Just
Well,
that. Just needed to use that there and that there. I don't know what it is.
Don't show part A.
Don't show that. Yeah,
I'm
so-
gonna do it to the reader, either I'm gonna start or kill you.
Oh no, or you should have put in a little square and as required at the end of
What's
everything. Every time we do that, it makes me feel like I've got it right, whether it's right. or
Yeah,
wrong.
yeah, just
Confidence is key.
Could put everything in a box.
So do you want to start on this one?
What?
is
I- Well, my problem is
I
that
think you
I
need to
wrote
start.
something yesterday.
That's more accurate, perhaps.
A generator is an element.
I'm better.
Oh, that's my answer.
Do
you want to see how- Yeah.
Yeah, so let's do a burst of activity now on question 2.
Yeah.
Still got 10 minutes. Continue. And then on Thursday, we'll present the solution. Thursday, we'll continue working on it.
I mean, it's up to them if they want to do it at home.
Was having a bit of a moment yesterday.
Yeah, I'd rather
You'd rather
go through it on Thursday.
the solution?
Yeah,
Okay.
do it.
can you please put the full
I
solution
will-
remove them?
I will be.
Yeah, I didn't write anything down.
But yeah,
doing
we'll scan Jan's page and that'll go on
But
the,
you said that
on the video.
some part of it is not complete. Can you add to it, please? Well, how can?
Yeah, but what
Yeah, but it's not-
it's not gonna, he wants us to talk about it first before he.
Well,
puts
you
the
remember,
answers.
so we had slight criticisms there about fully declaring assumptions. So that's, you should take that on board and it applies generally.
My problem is right with
Yeah.
like
You're
2D.
presenting your argument.
I know
Make it clear what the
that
assumption
S3
is.
is not cyclic.
That's the general point.
I know S3 is not cyclic. Okay.
Just actually
I think. Okay.
Go on.
What I instead did was prove that it
I'll
wasn't
tell you, I've
really.
got printed solutions. as well. But the printed solutions
might
may
be
well have
cyclic.
those deficiencies.
No, it's not. No. Yes. Wait. What if it's-
How you say in red?
Yeah. No. I don't think so. How do you prove it?
Say it out loud.
Oh, if the
Okay,
element.
so if you got any questions, queries about this, feel free to ask. But it makes sense to do a burst of activity on it. And we can either do a second burst at the start of the session and then talk to the solution in the second bit. Yeah.
Couldn't find like, I know what a generator of a cyclic group is, but I couldn't find a good definition in the book for just a generator of a group.
Okay,
Is
well,
it just,
you tell me now what it is.
is it just like an element of group that you can, I don't know the word that you can make a group around?
So just say,
Yeah.
say what you mean, first of all. Just what you mumble there. Say,
an element of a group that can, and then I need a word.
Well, you just said it.
Any of them
Create
in the group
any other element through what mechanism?
through the binary operation.
Through powers of that element. That's more or less it.
Oh,
So
depends if we
you
want
said
to find what power is.
you did find a definition for the cyclic subgroup generated by that. So you can just slightly augment that. A generator of the group is an element where the cyclic subgroup generated by the little g equals the big G. Yeah, you know the cyclic subgroup is a subgroup,
Generator.
but it's when that's equal to the
If
whole
it's a
group,
single, yeah.
then that G is a generator of the whole.
If there's more than one.
The whole group just is the
It's a
cyclic subgroup generated by
It's the
a
one.
particular element.
So is it two different definitions or one definition? That's how I'm.
Yeah, is that question?
Give the definition of a generator of a group and that,
So you want two definitions?
oh, hang on.
Yeah.
So I understand
That's
I'm
really
assuming
fine.
that
What
that tells us what a cyclic group is, tell you what a generator is.
Yeah, I'm assuming
you
that's
just-
how I interpret that. Give me the definition of generator and give me the definition of cyclic group.
But
Oh,
it
I
is
thought-
open to a
A
bit of
generator
a generator of
That's
group,
what I
generator of
assume it
cyclic group.
means.
Yeah,
Well,
because all thing you have to say is it's a single.
So you want two
What was
different
your meaning?
definitions here in this.
The definition of a generator of a group and the definition of a cyclic.
That's how I interpret
Yeah.
it.
Not generator of cyclic group.
Because they're both in bold.
Well, the generator of a
They
group
don't
and the
like
generator
one
of a
doesn't
cyclic
follow
group
from
is
the
the
other,
same
if that
thing.
makes sense.
Yeah.
It kind of makes sense.
Yeah, that's why I was getting
That's why
confused
I was
because I read it as
Because I would
As
have.
it is open to
generator
a
of
group
a
is
generator
different.
of a cyclic group or a generator.
But
Or
by
definition of
explaining what a
cyclic group
generator
or
of a cyclic group
generator.
is,
so you
describe
give the
what a
definition of a
cyclic group is.
generator of a group, like we were discussing.
Doesn't really matter.
And then after giving that,
Either way,
what's
your
the
answer is
definition of a cyclic?
literally, it's
Yeah,
not a
that's what I've
problem.
done.
What is it then? You tell me now.
Oh.
If we lay down,
That
if
they
we lay
are
down the-
generated by a power of something.
you know, but so we lay down the definition of what it is to be a generator of a group. Given that that's down and declared, what's the definition of a cyclic
It's
group?
got a single generator.
no.
No, it's
The
got
whole
a.
group, yeah,
Generated by
no,
whatever.
I'm,
So what did you do
Find the
about it?
Well, because it doesn't, not a single generator.
as in like,
Yeah, I know what
it's
you mean.
generated by
Yeah, okay.
that one
So,
thing.
Just very simply, a cyclic group is a group that has a generator. Yeah? That's all it is.
Mm.
Well, okay.
So it's really just assessing, do you know the meaning of the word cyclic?
Oh. See, I just assume
The
that's
group
like,
is cyclic if it has a generator.
assumed.
And the definition of a generator is one that produces all the elements through powers of the group operation.
It's almost like
Honestly,
that's
it's
how
lit.
cycles
Spend
work.
like half an hour
Hmm?
trying to
Almost
find
like
the
that's what a
definition
cycle
of
is.
just a generator and not
Oh.
generator as a cyclic group, and that's how I was getting.
I see, I
So you're saying the group is cyclic if it has a generator?
Yeah.
Okay. And what is the definition?
So a generator is a term that's applied
You
to
can
elements.
explain my solution.
Generator is an adjective for elements. Cyclic is an adjective for a group. So they're on a different level, kind of. But they're intimately connected. Yeah, it's the same. They're referring to two aspects of the same thing.
It's the way that's written is very
I just think no matter
Oh,
how
right,
you
yeah,
read it,
sorry,
you're still
yeah.
answering the question no matter what.
I
No
think
matter
we
how
can
you
do that
read it.
about
Yeah, but if I
it.
read that part A.
Okay.
Yeah, no,
and
even
then-
if you read it as give the definition of a generator and a generator of a cyclic group, you're still just answering what it is.
No, because I would be sat there going, that there isn't, like, what's the difference? I should know the difference. I don't know the difference.
Going confident, that's okay.
Shut up.
You
Pop
can't
kettle black.
When you get there.
I do think this sounds confident.
No, you don't. You go in such a wreck you can't speak to anyone around you.
I don't speak to anyone around me
No.
to not distract myself. I go in confident.
Come on,
Leave her alone.
Go confident, come out crying.
Yeah, like who talks to people before
Actually,
exam?
I came out
Some
of
well, some
the
people just don't
totally
like
surprised
need
with
any
how well I
like
played.
Kim's just Kim before. It's very nice. I just like
Well,
to
then
stay in
she
the
just
zone,
came
you
out
know?
and was like, oh
Yeah.
my God, I didn't even check the time.
I have to admit, I'm not confident.
Oh,
Oh, I'm not.
Oh no,
Fine.
guys, you didn't see me in
Especially
first year. I was not
And then-
okay, and then I just like got
What's that?
over
It's like, what have I done?
it and remembered that I can do exams.
It's fine. I don't
Uh,
No worries, man. I don't like tea. I wouldn't ask
These
this
prove or
question.
disprove questions are, you know, a harder version. You have to figure out which it is.
I feel like I would skip question 2 because I don't.
No, I quite
I,
like
do, I know you do because you like the
Yeah.
vague inkling towards number theory.
So
Vague.
is C yes or no?
Yes.
Yes. Okay. And is D yes or no?
Yeah,
Ah,
because it doesn't have a generator.
Yes, I'd have said D, isn't it?
yeah, okay,
Yes, straight
fine.
off the bat.
Okay.
You can't make that.
I know, but it does.
No, you can't.
There's no generator.
S3.
Ooh, boy, you're talking about dihedral groups.
Yeah.
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 S3
Oh,
is all of them. And you
It's
can't.
a hard question, this one.
Yeah. I mean, there's not that many elements in S3, so you could just go through and prove that none of them are a generator.
Exactly how many elements are there?
Six.
Okay. So you can look at the cyclic subgroup generated by each element and observe it isn't all 6 elements.
If it was any bigger, I'd cry.
I know, it's easy enough to.
I don't know.
None of those symmetric ones are.
What are they? One identity.
So the identity generates just the identity.
Yeah.
Some elements in
Three
S3.
transpositions.
3 transposition. What does a transposition generate?
Transposition.
It's self. Yeah. I don't know what to.
Order 2. So group itself and the identity. So transposition is order 2.
Mhm.
And the other type of elements are.
Three cycles. Oh, and they have to be order 3. Yeah, because they're 3 cycles.
A 3 cycle generates a subgroup consisting of 3 elements. The identity, int, and its square. So in each case, you've only generated maximum 3 elements.
I like it.
So there's nothing that generates the whole of S3.
That's easy.
It's all true.
That's good. I prefer that.
That's,
Don't curveball us. Keep it as
I don't like part E.
Oh, I love party.
No, I love
It's a
it.
fun proof. Yeah.
That number theory exam was actually enjoyable last year. Like, that's how sad I love proofs. That's how much I love proofs.
could you engrave that on a gold plate for me?
Genuinely.
And I'll nail it to the front of my
No
door.
word will lie. Number theory was my favourite exam last year.
I don't think
And all
so.
the nice
But it's the
videos
one
on
that
the
caused
end.
me most preemptive tears.
I didn't memorize enough things, so it was terrible.
It wasn't even memory. It was just after I'd written it out so many times. Like,
Killian went through the proofs that much that they're just
Yeah,
still
okay,
engraved
okay.
into my head.
oh,
I could not tell you a single thing from number theory. I could do the exam again this year, to be honest.
Proof of-
I
okay, we're-
felt that confident at the end.
I think you could ask an exam question, is SN cyclic?
And we
No.
could
Is that
just
cool or
yell
you have?
no.
I mean, well, I would give it more than 3 marks.
I guess you'd hope so.
Did you say wood?
It
So if
will
I just
always
say-
contain 3 cycles.
It's not cyclic or it's cyclic and it turns out to be correct. Which is so on.
Yeah, you get 1 mark too.
1 mark, no,
Kind
1
of
mark.
like it. All marks. No, that's not a proof, just a declaration.
I don't like part E.
Is it cyclic?
That's my conclusion of this.
No.
S3.
What's an even permutation? Definition of an even permutation.
Even number of transpositions to make it.
When you express it as a product of transpositions, there's an even number.
Yeah.
So why is the product of 2 even transpositions even? If I have in my hand an expression for 1 permutation as a product of transpositions, and I have in my hand the expression for the second permutation, sigma 2, as a product of transpositions, so I've got sigma 1 as a product of transpositions, sigma 2 as a product of transpositions. How do I get a product of transpositions for sigma 1 after sigma 2?
It depends. Is there any intersection? Because if they're disjoint, you
Because,
just
no,
just
they
put them all
don't,
up.
no, you can't write it as a disjoint for that.
No.
Yeah.
But no matter how you write it as equivalent transpositions, it's always even. Okay, that's the point.
But if I have them,
It's based
I just concatenate.
Throw them all together.
I just glue them together. Put the transpositions for one on the left.
Not that big,
Yeah.
no.
So it's sigma 1 after sigma 2. The transpositions for sigma 1 go here. The transpositions for sigma 2 go there. So how many transpositions in total? Well, it's an even number plus an even number. So it's got to be even.
Even.
Yeah.
Okay, yeah.
So therefore the product
Beating up
is.
someone's punch.
Product is even. You just got to write that down. Evidence that.
Where n is even. Is even.
Is a permutation of G.
A is even.
I can't solve the.
Yeah.
For part F, when he says is a permutation, so normally we think of permutations as a function on the set of labels 1 to n, but what's a permutation of the general set?
What?
Is it a reordering of it? I feel like I like that word.
No.
Yeah, well, already
Yeah.
it's expressed in, it's a function g to g, so what type of function g to g is a permutation?
Injected.
Keep going. Well, injective.
Yeah.
No, you gotta keep
No.
going.
I'm
Surjective.
An injective answer.
yeah, fine.
Bijective.
Bijective.
In fact.
If G was finite, you wouldn't have had to keep going. Injective is enough, but if it's infinite, you need that injective
Yeah.
answer. If it's finite, injective implies surjective. Yeah, there's a fair bit to do in that question.
Is it injected? So G equals GB, then like.
No, I mean in the whole question. there's a fair-
Oh, yeah.
Yeah.
That's what I'm saying. It's quite hard, yeah. I don't know who wrote it, but.
Okay, so work on that. Maybe we'll spend a little bit of the time on Thursday working on it, and then we'll go through the solution on Thursday. Does that seem fair?
Yeah.
Well, I prefer to
We go
keep it.
through this solution on
Yeah,
Thursday.
but I think the best medicine for everybody is to get a bit active with it.
Yeah.
Not just come and watch the discussion. So to try and do the solutions
So
yourself.
I keep saying, you won't learn to play the guitar by watching other people play the guitar.
Yeah.
That's false. Yeah, you can.
That is true.
That's exactly how I did it. Yeah, but you
No,
can't.
you got
No, but you
time.
also were tinkering
You
about
got-
like that. Was
Playing
I?
it yourself.
Yeah.
Was I?
Yeah, that's absolutely right.
You didn't pick it up and
But
play it
you
well
have
the first
to
time.
play